Hello students, in this video we'll discuss our fourth lab program, that is the perspective view of a color cube. In the previous video we have learned about color spinning of color cube and in that video we have discussed how to mark the vertices for your cube, how to consider the visible faces and invisible faces of a cube. All that we have discussed in the previous video. If you have any doubt in marking the vertices of the cube, you can just have a look of the previous video. And in this video also, we have a cube and we have to view the cube in a perspective viewing position. We have two viewing positions, that is orthographic view and perspective view. In orthographic view, the distance between the camera and the object is infinite. But in perspective view, the distance between the camera and the object is finite. Right? So camera and object is kept in a finite distance. Now, in this lab program, we will be discussing how I can view a cube by using this perspective viewing positions. And you have to be very conscious about using the viewing function. We know in graphics I have 2D diagrams and I have 3D diagrams. If it is a 2D diagram, my viewing function will be blue ortho 2D. And if it is a 3D diagram, my viewing function will be GL ortho. Ortho indicates it is orthographic view. But here in this program, it talks about perspective view. As I said, perspective view is nothing but the distance between the camera and the object is finite. Orthographic, infinite distance between camera and the object. So here for perspective view, the viewing function should be GL frustum. GL frustum should be the viewing position. Since we are rendering the cube as a 3D cube, right, on this viewing functions, right, it will have 6 parameters: x min, x max, y min, y max, and the z values, z near and z far. And remember very clearly, the viewing function for perspective view is GL frustum with 6 parameters, right, x min, x max, y min, y max, and the z near and far values. We'll start with our main. We are initializing our glut and we are initializing the display mode. Display mode, we are having 2 buffers, so it is double buffer, and the coloring system is RGB coloring system, and I am enabling my depth buffer because I am enabling the hidden surface removal algorithm. Hidden surface removal algorithm, or I can say depth buffer algorithm. So I'll be enabling this glut depth buffer also. And next I have to specify the window size. The first parameter is width, second parameter is height. So specify the width and the height of your output window, and you can create your output window and you can specify the title of your output window. And here we are having few callback functions. And the first callback function, reshape function, is for my window event. So when window event will occur, when I resize my window, when I resize my output window, window event will occur. And next is display callback function. And the third one is your mouse callback function. So if there is any mouse event, when I move a mouse, when I drag, when I click, right, this mouse function, mouse call event occurs, and the corresponding mouse callback function will be called. And the fourth one is I have keyboard callback function. So when there is any keyboard event, you will have this keyboard callback function, and it goes to the corresponding function definition. And as I said, I have to enable my hidden surface removal algorithm, so I am enabling it. You are enabling your depth buffer algorithm, GL enable. And last is your glut main loop. These are the functions in your main program. And we can see this reshape callback function. So whenever this event occurs, the corresponding function, the function name it is specified here, the corresponding function will be called automatically. And the name of these functions are known as callback functions. That is, when that event occurs, some values will be returned to that program. Right. So when I resize my window, some values will be returned to that reshape function. Now let us discuss what are those values returned to the my reshape function. So when a window event occurs, when I resize my window, when I maximize or minimize my window event occurs. Now, what will be returned to the program? What will be returned to the program when I maximize it? The corresponding width and height of my output window will be returned to the my reshape function will be returned to the program. Right. So those values are known as measures. We can see this my reshape function here. My reshape function. Right. So since it is perspective view, my viewing function is GL frustum. Right. So you can check here. Here in callback function, I'm not passing any values. But here you see my reshape function, it has width and height. How does it get these values? When that event occurs, right, at that time, what is the width and height of my output window that is given. So these values are known as measures. These values are known as measures. And here, when width is less than height, what you have to do? You have to divide it by width, h by w. You can see h by w, or else it will be w by h. If height is less than width, it should be w by h. Right. So you can use. Next is, what is the next function? Display function. Right. Display function. Where is display function here? And you can see your main function. I'm using double buffer. Right. Double buffer is color buffer and your depth buffer. So in display, I'm telling in every program, my first function in display function is clearing your buffers. So GL clear both the buffers, color buffer and the depth buffer. And here you have one more function known as glue lookup function. This is the 3D viewing function of my perspective view. Right, a 3D viewing function in perspective view. And this glue lookup function has 9 parameters. The first 3 parameters is the camera position. That is, who is viewing the object, the position of the viewer. Here camera is viewing, so the position of my camera, X, Y, Z. Next 3 is the eye position. Right. So the eye position, or I'll say is up vector. Up vector. This you would have learned it in your theory. And the last 3 function is at which point this eye is focusing. At point of your object, it will be focusing the object at which point it is focusing, at point, right? And next is the GL rotate function. This is for rotating the cube. You have to specify the angle and along which axis it has to spin, whether x axis or y axis or z axis. And here I am calling my color cube. I'm calling my color cube function. So where is my color cube function? Here, you know about these visible faces and invisible faces. If my front view is visible, right, I have to specify the visible faces in anti-clockwise direction and the invisible faces in the clockwise direction. This we have discussed in the previous video. Here I am rendering the faces of my cube. You know, cube, it has 6 faces: front, back, left, right, top, bottom. 6 faces. I am rendering it. And next is GL flush. You know it. Only if I use this GL flush function, my output, it will be displayed in my output window. And glut swap buffers, it is swapping between the front buffer and the back buffer. You know about this um, cube rotation, right? So I want to if I want to rotate my cube for this specified degree, I have to tilt my cube, I have rendered it. So rendering will be done in back buffer. Once rendering is done, it will be moved to the front buffer for displaying. When front buffer is displaying the object, back buffer, it should render the cube in the next position. All these things, it is done very fast. So we can see a spinning effect. So to swap between buffers, I need this swap buffers. So this is all about your glut display function. Next is glut mouse function. Right, glut mouse function. Here I am using this mouse event for rotating the cube. So as I said, when this mouse event occurs, few values will be returned automatically to the program. Those values are known as measures. And here, when a mouse event occurs, which button of the mouse I have clicked it, whether I have clicked the left mouse button or right mouse button or the middle mouse button. The button and the state of my mouse button, it is up or down, and the location of the cursor. When that event occurs, what is the location of the cursor? These things will be returned to the program. So you can see here mouse. Yeah. So you can see these are the measures, which button I have clicked, the state of my mouse button, and the location of my cursor, right? So button, left mouse button, it is down. So if I click my left mouse button, I have written I should rotate along x-axis. If I click my middle mouse button, I have to rotate along y-axis. And if I click my right mouse button, I have to rotate along z-axis. And this rotation, every time it has to be tilted by 2 degrees, and you have to rotate it. Right, that's what I have specified this to. And next is you have this keyboard event. You know, when there is any keyboard event, this keyboard callback function will call which function? Keys function. So when keyboard event occurs, so which key of the keyboard I am pressing, right? That has to be known to the program. So the corresponding ASCII value of that character will be returned to the program. So if I press A button, A key, the corresponding ASCII value of that letter will be returned to the user program. So, and yeah, and the location of the cursor, right? X and Y position. So here, if I press this, so here, what is the aim of this program? Perspective view of my color cube. So if I press my small X button in my keyboard, I am viewing my perspective. I am viewing my cube along x-axis. That is, I am moving the object far away from the camera. Along x-axis, I am moving the camera. Right. So if I move the camera far away from the object looks smaller. Right. So it is like zoom in and zoom out effect. Right. So if I bring the camera close to the object will look bigger in size. So if I press my small x button along x-axis, I am moving the camera far away from the object. If I am pressing the capital X button, I am bringing the camera close to the object along x-axis. Move the camera along x-axis. Right. And next is capital small y, moving the camera far away from the object along y-axis. Capital Y is bringing the camera close to the object along y-axis. Move the camera along y-axis and bring it near to the object. So you can view the object bigger in size. And next is small z, moving the camera along z-axis. Moving the camera far away from the object along z-axis. Along z-axis, you move the camera so that the distance between the camera and the object is more. Object will look smaller in size. Capital Z means bringing the camera close to the object Right, you are moving the camera along Z axis and bringing it close to the object so that you can view the object bigger in size. So these are some keyboard events. Right, so here, hope you would have understood, we are viewing the object in perspective position. Perspective position means distance between the object and the camera is finite. So you can move the camera close to the object, you'll see the object bigger in size. If you are moving the camera far away from the object, you can see the object smaller in size. It is like your zoom in and zoom out effect. Hope you would have understood it. Thank you.